Introducing CHCNAV's new ViLi i100 Visual-LiDAR GNSS receiver, redefining Flagship GNSS with revolutionary innovation. Powered by next-generation 860,000 points per second LiDAR fusion, ViLi i100 accurately captures surrounding 3D spatial data in GNSS-obstructed environments, intelligently analyzes satellite signal paths, and auto-filters multipath errors caused by obstruction or reflection. Even in narrow alleys, dense forests, or near high-rise buildings, it delivers confident and consistent 5 centimeters absolute accuracy. No matter how many times you measure, your position stays right. Once right, always right. With the enhanced SFix 2.0 engine, ViLi i100 ensures reliable 5 centimeters accuracy within 20 meters, even in GNSS-denied areas. Using high-density LiDAR data with SLAM-based angular constraints, trained on tens of thousands of real-world scenarios, optimized for complex field conditions. No need to switch total stations. Experience true GNSS anywhere, even in GNSS-denied areas. High-precision laser sensing enables real-time 3D point cloud earthwork calculation. With Landstar software, just scan and define boundaries to get 99.98% accurate cut. Fill results instantly on site. No surface contact needed, combining precision, efficiency, and safety in one workflow. ViLi i100 supports Vi-LiDAR contact with survey using laser data, capturing one photo to instantly extract multiple 3D coordinates with 5 centimeters accuracy up to 15 meters. Capture first, select later. No need to aim, stay steady, or align the range pole, eliminating hand tremors. The 8-megapixel telephoto camera delivers clear visuals even when zooming from long distance. With the latest Landstar software, ViLi i100 integrates all conventional GNSS features in one flagship receiver. CAD-AR visual stakeout boosts efficiency by up to 50% and supports NTREP, UHF base rover, and PPP modes. ViLi i100 Visual-LiDAR GNSS RTK receiver. Now, you can trust every fix.
Hi everyone, I'm Rachel from CHC Navigation. It's so great to be here with you again, reconnecting with so many familiar faces from last year's product launch, and extending a warm welcome to those joining CHCNAV's today's event for the first time. This is our global moment, and we're all here for something more important than just launching a new product. It's about moving forward together, taking a meaningful step that solves the real daily challenges you face when positioning in tough and complex environments. The limits we have all worked around, they are about to change. Let's start the journey together. The surveying industry moves forward because of great tools, and over the last 30 years, the GNSS receiver has been one of the most game-changing. First, we know Trimble. One of the top companies pioneered it. They packed complex workflows into a single device, making measurement portable and efficient at last. Next, innovation stepped with IMU integration. Now you could tilt measure, point collection, and stakeout got way faster. Then a big leap came with full constellation and full frequency support. Then we had higher accuracy and stronger stability, even when you are in harsh environments. And lately, we see intelligent fusion, visual and laser-integrated GNSS receivers combining what you see, spatial data, and cloud services. that pushing what GNSS receivers can do. Every step we break positioning limits, we help our surveyors work steadier and go further. But here is the thing. Even with all this progress, some big challenges still hold you back. Yes, challenges remain. In cities, dense buildings will block some of the GNSS signals. Sometimes we can get fixed, sometimes we don't. In old neighborhoods, narrow gaps between buildings leads to inconsistent accuracy. We measure the same point twice, but the numbers don't match. In forestry, canopy reflection ruins reliability of accuracy. These GNSS obstructed sceneries are the daily headaches of every surveyor, and they remain one of the biggest challenges that conventional GNSS receiver on the market still cannot solve. It gets even harder in fully GNSS-denied areas, under eaves, in underpasses, on construction sites. There is simply no GNSS satellite signal. Conventional GNSS receiver cannot get fixed here, and switching to total station takes extra time. So what used to be just a measurement gap now turns into a project delay. Beyond that, dangerous and hard-to-reach areas are another barrier. Yes, there have been innovation solutions trying to solve these problems, but they are still far from perfect. Take laser survey for example. When aiming at distant points, even the slightest shake throws off the target, and accuracy suffers. So at this time, we often need an additional pipot to assist. Or visual survey. We take a photo or video, and then we wait on site for the processing. Efficiency, safety, accuracy. How can we balance all three? That's a question. And for our field operators on construction sites, the challenges continue. Whether it's earthwork value calculation or stakeout in complex environments, the story is the same. No efficiency, poor accuracy, and unsafe operations. GNSS obstructed areas, GNSS denied areas, hard to reach and dangerous sites, complex construction environments. These are the real-world challenges surveyors and field operators face every day. And they are also the next challenge our industry must overcome. This is why we have invested a lot in R&D and innovation to crack these limits of spatial temporal positioning. And finally, we find that through the deep fusion of multi-source sensors, combining GNSS, LiDAR, ultra-MU, and multi-visual data, we can cross-check GNSS signal, intelligently filter out unreliable ones, and build a truly robust positioning model. This is the key to achieving reliable accuracy, even in GNSS obstructed and denied environments. And it is the breakthrough that brings us to today's highlight, the ViLi i100 Visual-LiDAR GNSS receiver. ViLi i100 is CHCNAV's new flagship, redefining what an industry flagship GNSS receivers can do. In GNSS obstructed areas, it delivers confident, consistent accuracy. Once right, always right. When conventional GNSS receivers struggle, ViLi i100 performs. In GNSS denied areas, SFix 2 provides reliable 5 cm accuracy within 20 meters, even where conventional GNSS receivers cannot get fixed. For construction teams, especially on earthwork projects, ViLi i100 provides real-time 3D point cloud calculation, accurate, fast, and safe. In hard-to-reach and dangerous areas, ViLi i100 offers Vi-LiDAR contactless surveying, capture points without aiming perfectly or staying steady. Surveying becomes smart and safe. And beyond all these innovations, ViLi i100 remains a fully reliable all-in-one flagship GNSS receiver with every conventional features you rely on. With ViLi i100, now you can trust every fix. And now let's talk about the first and most essential feature of ViLi i100. Confident and consistent accuracy in obstruction. Once right, always right. In cities, forestry, or narrow alleys, when GNSS signals are obstructed, accuracy cannot be a guess. It has to be reliable every single time. ViLi i100 is built to make sure every measurement counts, even in GNSS obstructed areas. So, how do we make that happen? The challenge in GNSS obstructed areas has always been multipath errors. Satellite signals bouncing off buildings, trees, and other obstacles. That's what makes positioning unreliable. And the ViLi i100 crushes this. It starts with the multi-sensor fusion. ViLi i100 features a next-generation LiDAR sensor that scans at 860,000 points per second. That's 3 times faster than conventional GNSS systems with LiDAR fusion. In GNSS obstructed areas, ViLi i100 actually detects 3D spatial data of surrounding building in real time. It builds a clear, dynamic environment map that shows how positioning stays accurate. After detecting the surrounding spatial information, ViLi i100 intelligently analyzes satellite signals in real time and automatically filters out those affected by multipath error caused by reflection or obstruction. This is ViLi i100's breakthrough multipath auto-filtering algorithm. It solves one of the toughest challenges in RTK positioning: inconsistent coordinates caused by ambiguous fixed in complex environments. And the result: stable, jump-free positioning with confident and consistent 5 centimeters absolute accuracy, even in narrow alleys, dense forests, or near high-rise buildings. No matter how many times you measure, your position stays right. Once right, always right. From May until today, over the course of more than 4 months, we took ViLi i100 on a global journey. Teams from R&D, product, and technical departments traveled to more than 10 countries and regions, testing in real-world environments across cities, dense forests, narrow alleys, and complex construction sites. The goal is simple: to continuously optimize ViLi i100's accuracy and reliability across a wide range of GNSS obstructed conditions and the real operation scenarios. Now, let's look at the results. We compared ViLi i100 against a top global GNSS brand known for high precision and stability, as well as the latest conventional GNSS receiver from another brand. In CHCNAV internal lab, we conducted over 1,600 multi-sceneries measurements, covering old neighborhoods, dense forests, and high-rise buildings. The results speak for themselves. In heavily obstructed environments, ViLi i100 achieves 5 centimeters accuracy, 95% of the time, improving reliability by 22.9%, compared with conventional GNSS receivers, which achieved only 72.2%. Repeated measurements returned consistent accuracy, demonstrating a clear advantage over conventional GNSS receiver. This isn't just an improvement, it's a reliability revolution. ViLi i100 sets a new benchmark for accuracy and reliability in the field. And here on the screen, you can see the comparison of multiple measurements of the same control point across different GNSS receivers. And look closely. In severe obstruction, ViLi i100 maintains consistent, reliable accuracy, outperforming every other brand in all tested scenarios. Once right, always right. This is why we proudly say confidence and consistent accuracy in obstruction. ViLi i100 is built for surveying in the most challenging GNSS obstructed environments. Last year, when we introduced the RS10 with SFix 1, we had a big vision in our mind: to give surveyors a technology they could truly trust in complex environments. Before that, measuring in harsh environments means dealing with inconsistent coordinates and unreliable accuracy. SFix 1 changed that. For the first time, surveyors could count on stable, reliable positioning. Over the past years, other brands have followed with new positioning technologies. Some call it laser reverse positioning technologies, others GNSS and SLAM hybrid combo. But the truth is clear. The foundation of these approaches come from SFix 1. It's rewarding to see the industry recognize this new technology. But innovation never stops. And that brings us today here. With ViLi i100, we are introducing SFix 2. If SFix 1 opened the door to obstructed environment surveying, SFix 2 pushes it wider and steadier. The biggest upgrade of SFix 2 is that reliable 5 cm accuracy within 20 meters, even in GNSS denied areas. From SFix 1 to SFix 2, we spent a whole year continuously iterating, optimizing, and pushing boundaries. Our mission has never been changed. We don't follow. We need the industry. And today, that vision is built right into ViLi i100, ready to conquer the points that once seemed impossible. And now, let's take a closer look at a situation many surveyors know all too well.
Fixed, let's go. As long as I run fast enough, the float solution can't catch up with me. Oh no GNSS signal anymore.
To measure a point under a temporary shed, under an eave, or even under a bridge, surveyors often have to get fixed in an open area, sprint in, and hope they press the button at just the right moment. We call this the self-deception survey method. It's more than a trick. It's a daily challenge. Satellite signal denied. Conventional GNSS receiver just won't work. And surveyors have to bring in total station, heavy, slow, and cumbersome, just to get a few points. With ViLi i100, those days are over. The another heart of ViLi i100 is the all-new SFix 2 engine, a true breakthrough for fully GNSS denied areas. In areas with no GNSS signals, SFix 2 calculates RTK coordinates using 3D LiDAR ranging data and SLAM-based angular constraints. This is real multi-sensor fusion, and this is what sets SFix 2 apart from conventional IMU integrated GNSS. Here is the difference. In a fully GNSS denied areas, traditional IMU RTK GNSS is like walking blind in the dark. Eventually, you drift off course. SFix 2 is like walking with a flashlight. LiDAR ranging and SLAM provides continuous positioning and orientation. So even when GNSS signal disappears, you stay on the right path. So the result is that in areas where traditional GNSS couldn't get fixed, ViLi i100 keeps going, reliable, stable, precise. SFix 2 isn't just about handling GNSS signal block. It also brings major improvements in positioning stability and fault tolerance. Thanks to the next generation 860,000 LiDAR points per second, the engine gathers richer future inversion observation information, greatly enhancing SFix positioning reliability. And trade on tens of thousands of scene rays tested with RS10 and SFix 1. SFix 2 has undergone extensive fusion and iterative training. What does that mean in practice? It calculates accurately and consistently, even in the most complex and challenging field conditions. In other words, reliable results every time. Finally, let's bring it back to what matters most, the final user experience. With ViLi i100, surveyors can now measure up to 20 meters in fully GNSS signal denied areas with confidence, maintaining stable 5 centimeters accuracy. No need to switch to a total station, no optical instruments, just ViLi i100. This is what we mean when we say that ViLi i100 redefines true positioning. Now you can trust every fix. To see SFix 2 in action, let's look at the real-world project case. Many of you have experienced this. During a topographic survey, everything goes smoothly until you hit a single GNSS signal denied point, a doorway under an eave, for example. Completely blocked, no GNSS signal. Conventional GNSS receiver just cannot get fixed. What do? You have to switch to a total station, right? Heavy, cumbersome, time-consuming, a headache we have all faced. So we put ViLi i100 to the test. The same point was measured 10 times, and every measurement stayed within 5 centimeters of the accuracy of the total station results. That is confidence you can rely on. Another common challenge: measure points under bridges and overpass during road mapping or as-built surveys. These points are often in complex GNSS shadows, blocked from every signal. Traditional GNSS just cannot handle it, and surveyors against have to rely on total stations, slow and inefficient. With ViLi i100, we repeat measurement under these bridges, and the result consistently stayed with 5 centimeters compared to the total station benchmarks. And finally, the narrow alleys of dense building block. Tall buildings on both sides create complex GNSS signal denied areas. We run multiple repeated measurements in these narrow alleys and compare them with the total station results and see the results. Reliable stability and accuracy every time. Across all 3 sceneries, doorways, under eaves, point, and bridges, and narrow alleys, ViLi i100 delivers reliable, consistent measurements. This proves that the SFix 2 enables surveyors to confidently measure up to 20 meters in fully GNSS signal denied areas without switching to a total station. Earlier, we have talked about GNSS obstructed and GNSS denied areas, challenges every surveyor knows. Next, let's talk about construction work. For construction team, especially on earthwork projects, field operators face 3 big challenges: efficiency, accuracy, and safety. First is efficiency. Large-scale earthwork means collecting hundreds, even thousands of points, point by point, to generate a service model. It's slow, it's exhausting, and there is always the risk of missing points. And some software requires post-processing before you can even generate a route. More steps, more time. Second, accuracy. Different terrains demand different point densities. Features must be filtered carefully. Mistakes here mean rework, wasting time and resources. Third, safety. To capture points on earthwork piles, field operators often have to climb ridge with GNSS receiver. It's hot, tiring, and in some cases, it's dangerous. Anyone who has done it knows exactly what that feels like. This is exactly what ViLi i100 steps in. We want to rethink earthwork surveying from the ground up to solve the efficiency, accuracy, and safety challenges field operators face every day. With 3D point cloud earthwork calculation, ViLi i100 doesn't just make the job easier, it transforms the workflow. First is the accuracy. With ViLi i100, high-precision laser sensing combined with the NanoStar app filters out noise and delivers real-time cut and fill value calculation, right on site with extreme high accuracy. No more guesswork, no more rework, just precise, reliable results every time. Next, speed. Earthwork calculation happens in real time. Just scan defined boundary and get instant results directly on site. No waiting, no extra office work, just a smooth, seamless workflow from start to finish. And finally, safety. ViLi i100 enables non-contact measurement. No need to climb piles of physically touched surface. so operators stay safe while measurements stay accurate. In one workflow, ViLi i100 transforms earthwork surveying, combining accuracy, efficiency, and safety. Its 3D point cloud earthwork calculation redefines for the modern construction site. And next, let's see a real case showing how ViLi i100 transformed the earthwork value calculation. Take a look at this pier, nearly 70-degree slope, over 5 meters high. In this no-fly zone, drones are out. Traditional GNSS models, slow, exhausting, and unsafe, forcing surveyors to climb and take risks. And now, watch what happens with ViLi i100. Surveyors simply walk around the pier from safe distance, completing a full 3D point scan of the whole surface. And thanks to the next generation LiDAR sensing, ViLi i100 collects massive real-time 3D points clouds, capturing every detail of the pier. And with LiDAR software, dividing boundary is easy. Redundant points are automatically filtered, and on-site value results are calculated, always high accuracy. And here is the best part. No context measurement, no climbing, no risk, just safe, all in real time. ViLi i100 turning accuracy, efficiency, and safety into one seamless earthwork value calculation workflow. Also, during surveying, some points are hard to reach or carry safety risks. With ViLi i100, we introduce Vi-LiDAR contactless survey. It's a fully contactless workflow, giving you a safer, faster, and more reliable way to measure. And this is where ViLi i100 Vi-LiDAR really shines. Traditional solutions have clear limitations. The laser surveying requires precise aiming at a distance point. One small shake and your coordinates are off. And the farther targets, hard to see even the laser dot. How about visual surveying? You take photos or videos, then wait for post-processing on site. It's inefficient and often interrupts your workflow. And now, let's see how ViLi i100 turns this around with Vi-LiDAR contactless survey, overcoming these limitations and redefining how contactless survey is done. With Vi-LiDAR, it takes a photo first, capture points later, and instantly extract multiple 3D coordinates. No need to aim perfectly, no need to stay rock steady. No precise alignment with the range pole. Errors caused by shake hands, let's say bye-bye. So Vi-LiDAR eliminates hand tremors and reduces user errors, ensuring fast and reliable results from a safe distance. And its 8-megapixel telephoto camera captures sharp visuals up to 15 meters. Even in complex, hard-to-reach areas, Vi-LiDAR maintains 5 centimeters accuracy. In short, Vi-LiDAR contactless survey gives you a safe, precise, and effortless way to measure hard-to-reach and dangerous areas, overcoming the limitation of traditional laser and visual methods. Ladies and gentlemen, today we have just scratched a part of what ViLi i100 can do. As a true industry flagship, its capabilities go far beyond what we have shown. ViLi i100 is all-in-one, packing every conventional ArcGate feature you rely on in a single, compact device. Powered by LiDAR software, which is the most popular field survey app in the world, loved by more than 500,000 surveyors worldwide, surveying and stakeout becomes effortless. It combines all the trusted ArcGate functions you know with next-generation innovations designed to push your productivities further, all in one device. And with CAD AR visual navigation and stakeout efficiency can be improved by up to 50%, letting field teams work faster and smarter. And with full mode support, the N-Trip, UHF-based rover, and PPP service, ViLi i100 adapts to any job site, any environment, delivering high precision results every time. and that is the ViLi i100 Visual-LiDAR GNSS receiver. Let's recap its 5 game-changing advantages. The first, once right, always right, confident and consistent accuracy in obstruction. And the second, SFix 2, reliable 5 cm accuracy within 20 meters, even in GNSS denied areas. And the third, real-time 3D point cloud Earthwork calculation, accurate, fast, and safe. And the fourth, Vi-LiDAR contactless survey. Take a photo, capture points later. No need to aim or stay rock steady. And the final one, all-in-one flagship GNSS receiver. Every conventional feature you expect integrated into a single compact device. So, with ViLi i100, now you can trust every fix. Alright, now let's watch a short video showcasing all the awesome features of this industry flagship GNSS receiver, ViLi i100 Visual-LiDAR GNSS receiver.
Introducing CHCNAV's new ViLi i100 Visual-LiDAR GNSS receiver, redefining flagship GNSS with revolutionary innovation. Powered by next-generation 860,000 points per second LiDAR fusion, ViLi i100 accurately captures surrounding 3D spatial data in GNSS-obstructed environments, intelligently analyzes satellite signal paths, and auto-filters multipath errors caused by obstruction or reflection. Even in narrow alleys, dense forests, or near high-rise buildings, it delivers confident and consistent 5 centimeters absolute accuracy. No matter how many times you measure, your position stays right. Once right, always right. With the enhanced SFix 2.0 engine, ViLi i100 ensures reliable 5 centimeters accuracy within 20 meters, even in GNSS denied areas. Using high-density LiDAR data with SLAM-based angular constraints, trained on tens of thousands of real-world scenarios, optimized for complex field conditions. No need to switch total stations. Experience true GNSS anywhere, even in GNSS-denied areas. High-precision laser sensing enables real-time 3D point cloud earthwork calculation. With Landstar software, just scan and define boundaries to get 99.98% accurate cut. Fill results instantly on site. No surface contact needed, combining precision, efficiency, and safety in one workflow. ViLi i100 supports Vi-LiDAR contact with survey using laser data, capturing one photo to instantly extract multiple 3D coordinates with 5 centimeters accuracy up to 15 meters. Capture first, select later. No need to aim, stay steady, or align the range pole, eliminating hand tremors. The 8-megapixel telephoto camera delivers clear visuals even when zooming from long distance. With the latest Landstar software, ViLi i100 integrates all conventional GNSS features in one flagship receiver. CAD-AR visual stakeout boosts efficiency by up to 50% and supports NTREP, UHF base rover, and PPP modes. ViLi i100 Visual-LiDAR GNSS RTK receiver. Now, you can trust every fix. Introducing CHCNAV's new ViLi i100 Visual